Okay, so in the isotope dating activity, the first part is the decay series of uranium 238. So this table was given to you in the assignment sheet, and it is called the decay series of U-238 because it lists out each individual decay process that happens from the parent U-238 all the way until the final daughter atom at the end of step 14, because it takes 14 steps to go from uranium 238 into our final stable daughter atom. And I mentioned that if you did the decay series correctly, that you would find the final stable daughter atom to be lead 206. So this is the final step here if we've done our decay series correctly. And I mentioned that in class last time we were together. So how do we get there? Well, we have to remember what these symbols mean. So alpha means that we are undergoing alpha decay, and that means that we emit the alpha particle. Now, remember what we talked about with the vocabulary, that emit is a word that means put it on the right. So for each of these steps, the particle listed is going to appear first on the right side of the arrow. And beta, the other symbol that you see, represents the beta particle or the electron. And again, that means that the beta particle is emitted in that step. So the first few steps I've completed for you, just like we did in class together. So at the beginning of step 1, our parent atom is uranium 238. So remember that the mass number is at the top left, 238. The atomic number is at the bottom left. And on the periodic table, we find that uranium is element number 92, and its symbol is U. Now, the table says that the first step is an alpha decay. So that means that we emit the alpha particle. So you'll see that I've put the alpha particle on the right side of the arrow. And now we had to solve for the daughter atom of step 1. So if you're on opposite sides of the arrow, you are subtracting. So to calculate 234 as the daughter's mass number, what I did is I subtracted 4 from 238. So 238 minus 4 gave me 234. I did the same thing to solve for the atomic number of the daughter atom. So I did 92 minus 2 is equal to 90. And then on the periodic table, element number 90 is thorium, and its symbol is TH. And that is how we found the daughter atom from step 1. Now, the fun part is this is a cascade, it's a series. So that means that the daughter that you make at the end of the step becomes the parent at the beginning of the next step. So when I start step 2, I'm going to be starting with thorium 234. And in my table, I'm told that step 2 is a beta decay. And that means that we are going to emit the beta particle. So I'm going to put the beta particle first on the right side of the arrow. And I solve for my new daughter atom. But we did the same thing. 234 minus 0 gives me a mass number of 234. Now 90 minus negative 1. So remember what happens when you subtract a negative. It actually turns into addition. So you keep the original sign, you change the subtraction to an addition sign, and you change the negative sign to a positive. So 90 minus negative 1 actually turns into 90 plus 1. And that is how we solved to find the atomic number is 91 of the daughter atom in step 2. And on the periodic table, element number 91 is protactinium with a symbol Pa. So protactinium 234 is our daughter from step 2. So just like we did before, at the beginning of step 3, we're going to take protactinium-234 and make it the parent atom in step 3. Now my table tells me that step 3 is also a beta decay. So in step 3, I will emit the beta particle again. So I put it on the right side of the arrow and I solve for my new daughter atom. So 234 minus 0 is 234. 91 minus -1 turns into 91 plus 1. So that is how we found the atomic number 92. And that is uranium. So you might be thinking, wait a minute, I've gone backwards. And in one case we did, because we did turn back into uranium, but not the same isotope of uranium that we started with. We started with uranium-238, and now we have uranium-234. So it's a different isotope of uranium. So even though it might seem like we haven't done anything, we're getting closer to having a stable isotope, because stability is all about that ratio of protons to neutrons in the nucleus. And if I'm changing my mass number, that means I'm changing the amount of neutrons that are there. So that ratio is changing. So we're moving toward being stable. So don't let that throw you off if you start to see that you're back seemingly where you started, because you're still going on the right track. You're still changing that mass number, changing that number of neutrons, and ultimately moving closer and closer to being stable. So now that I know that the daughter atom of step 3 is uranium-234, that means in step 4, uranium-234 is the parent. And step 4 in my table is given as an alpha decay. So that means that I'm going to emit the alpha particle first, and I need to solve for my daughter atom. So for the mass number, 234 minus 4 gives me a mass of 230. To solve for my daughter's atomic number, I'm going to do 92 minus 2, which gives me atomic number 90. And from my periodic table, I know that element number 90 is thorium with the symbol TH. So my daughter atom at the end of step 4 is thorium-230. Since this is my daughter at the end of step 4, it means it's also my parent at the end, at the beginning of step 5. So thorium-230 is my parent in step 5, and my table tells me that step 5 is an alpha decay. So we're going to spit out the alpha particle and emit that first. So it's on the right side of the arrow, and we'll solve for my new daughter atom. So for the daughter's mass, 230 minus 4 is 226. To solve for my daughter's atomic number, 90 minus 2 is 88. And then on my periodic table, I find out that element number 88 is radium, and the symbol is Ra. So Ra for radium. So radium-226 is my daughter atom at the end of step 5. Since this was my daughter at the end of step 5, it's also my parent at the beginning of step 6. So radium-226. Step 6 is also an alpha emission. So alpha decay means that we emit the alpha particle. So we put it on the right. And now we solve for the new daughter. So for my daughter's mass number, 226 minus 4 is 222. To solve for my daughter atom's atomic number, 88 minus 2 gives me 86. And then I go to my periodic table and I find that element number 86 is radon. And radon has the symbol Rn. And that is the pattern that you'll follow as you go step by step all the way through until step 14. And as I said, if you've done it correctly, all the intermediate steps, you should find that step 14 starts with polonium-210 and that the final daughter is lead-206. Hope that helped.